Hello guys, welcome back to Maison African Motives. Still working on our Mechanotechnics N5 revisions. So in this platform, we shall be focusing on the reduction gearbox in this case. So we just want to see how do they ask these questions. So this is Feb 2022 exam that we are given in this case. So we are going to consider this question and see how we are supposed to attempt this typical question. So if you are to check, you are given fig 1 below shows two shafts C and D. So we are given the shaft C and D in this case in the same line. So this is actually in the same line. The C and the D is in the same line, geared together through an intermediate parallel shaft E. So that is our parallel shaft E. The gears connecting shafts C and E have module. These are the modules that you are given. So in this case, we are going to refer the C, in this case, that is our input, to D, which is given as the output in this case. So we have in this case, or we are given that the gear connecting shafts C and E, that is this shaft C and E, which gears are we talking about in this case? We are referring to F and G in this case. We are referring to F and G. We are given the module there is 6. So we have got the module in this case that is between shafts F and G. So between F and G. So we've got the module, which is M between the shafts it's actually between C and E, that is the shafts C and E. So we are referring to the gears in this case, that is F and what? That is F and G. So we are going to consider F and G is equal to 6. So we are given this module here is equal to 6. That is between the points that we are given C and E. Then between E and D, we are considering J and H. The module there is 8. So we are given the module. Now considering J and H, we have got a module of 8 in this case. All right. Then the pinion that meshes gear J in this case, the pinion that is meshing gear J, this is our gear J in this case. So which pinion are we talking about? We are referring to H in this case. Yes, got 24 teeth. So meaning to say we are given the teeth of H, which is 24. So TH is equal to 24, the teeth of H. Then the speed of the shaft D, take note, the speed of the shaft D, this shaft here, is 1/10. That is 1/10 of the speed of the shaft C. So this speed of D is 1/10 of the speed of the shaft E. So what does it mean? It's a ratio that we are going to consider. The speed of the shaft D is equal to 1/10 of the speed of the shaft C. That is the speed of C. So it's 1/10 of the speed at C. Then we are given that the ratio of each reduction is the same. The ratio of each reduction, there is a reduction here. Since F is driving G in this case, H driving J, so we are going to see the ratio between these is the same. So we're given that the ratio of the reduction is the same. So take note, the ratio of reduction is the same. So the ratio of reduction is same. All right, the ratio of reduction in this case is the same. What does it going to affect us? It is also going to affect the center distance in this case, meaning to say also the center distance is the same. The center distance is also the same, is also equal. So that is what's going to happen in this case, meaning to say the center distance between the gear F and G and also J and H, we are going to have the same center distance. That is where we are going to apply these modules that we are given here. All right, so that is the information that we are given. So the question is calculate the number of teeth from this information. Calculate the number of teeth on gears F and G. So gear F and gear G in this case, we need the number of teeth on these gears. So we need TH, all right, that is TF, sorry, the teeth of F and G. So we need F and G in this case. So we do not know these two, TF and TG, we do not know. So what are we going to do? What are we going to consider? Whenever, guys, we are dealing with the reduction, we are supposed to be thinking of the ratio of speed, the input speed over the output speed considered to the number of teeth of the driven and the number of the teeth of the drive. That is the whole concept of this topic. So let us get back to the formula. We know that the input speed, we talked about this, that the input speed over the output speed, speed in this case is going to be equal to we are referring in this case the number of teeth of driven gears, the driven gears on top. So we are simply considering the product there. We are simply considering the product of the driven, okay? The product of teeth, the product of teeth on driven, the product of teeth on driven gears in this case, all right? Over the product of teeth on the drivers, the product of teeth on the drivers in this case, on the drivers in this case. So we're going to consider the drivers and the driven in this case. All right. So the actual formula was supposed to be number of teeth of driven gears, number of teeth of driven gears on top over the number of teeth of driving gears. That is the proper formula. This one is a manipulation because we are going to consider the product because there is a meshing of teeth that is happening. The other gears meshes to this, the other gear meshing to. So what you need is to know which one is driving which one, which part is driving another part. So we considered that in this case, we are going to see that F on the input, F is going to be driving G in this case. So we are going to consider F drives G in this case, all right? After this linkage, we are going to see H is going to be driving J. So this H is going to drive, so it drives J in this case. These are the gears that we are considering. So meaning to say G and J, these two, are the ones that we see on the driven. They are the ones that are being driven by what? These two are the drivers. F is the driver, H is the driver. So meaning to say on the driven, we are going to consider our formula because we remember we are saying the input speed, all right? The input speed, what is going to be the input speed, all right? Here on we said the input is C and the output is D. So meaning to say the input speed, which is NC. Remember our input, let us just change. The input is at C, so we are going to have NC over the output, which is at D, the speed of the shaft there at D. This is going to be equal. We consider now the product, now like we consider the product of it on driven. And we are saying the ones that are driven here, it's G and J. So we're going to consider the teeth of G times the teeth of J, all right? Over corresponding, G is corresponding from its driver F, the TF times J is corresponding from its driver. The driver there is H. So it's going to be TH. So that is the whole idea. That is the whole idea there. But remember now about the ratio here, because we are going to consider two things here. One, the simplification of this ratio of NC over ND, because here we are given a certain consideration that you're supposed to work with, that ND is equal to 1/10 of NC, which we shall see that one later on. But remember, the question is to find TF or TG. These are the ones that we need to find this and this. We do not have TJ. We have TH in this case. TH, we have it. But TJ, we do not have. So we are going to consider formulating or formulation of equations here. How are we going to formulate our equations? Let us consider the first thing that we are having here. We are told that the ratio of reduction is the same So if the ratio of reduction is the same, what does it mean? It means that the ratio of the driven part over the driver part, this one of TG and TF, is going to be equal to TJ over what? Over TG. We are going to consider the same ratio. So we are saying the ratio of TG over TF, all right? The ratio of TG over TF is, this case, is going to be equal to TJ over TH. So we're going to have TJ over TH in this case. They are equal, the ratio is the same. So if they're equal, it means these two, they are equal. So I can write TG in terms of TJ. I can write TJ as TG. I can write this way, the way that I want. So if I can write TG in terms of TG, I'm going to have this ratio here as NC over ND is equal to, I'm writing in terms of TG, meaning to say this TJ is now written as TG. So I'm going to have this TJ as TG. So TG times TG, I'm going to obtain TG squared over, if I'm to write also this second equation in terms of TF, it means TH is equal to TF. These two, they'll be equal. So I'm going to have TF squared. But that is not the only way, because we are saying this is the same. So if I wanted to write in terms of the last part, which is TJ, I was going to have this as TJ. So it was going to be TJ times TJ, which is TJ squared over, in terms of the last part, which is TH, it was going to be TH. This one also same as TH. So it was going to be also TH squared. So this is what we can formulate, because we're saying they're equal, because we're simply saying TG is equal, these two, they are equal. TG is equal to TH. TG is equal to TJ, I mean. So if they're equal, I can write TG as TJ. I can write TJ as TG in place. So meaning to say we are going to formulate two equations. I are going to formulate two different formulas from this. So how are you going to work with this? Because of what you are given, you are going to choose a formula from what you are given here. If we check, we are given, we do not have TJ, which is true, but we have TH in this case. TH is given. Here we need to calculate TG. We need to calculate, so we are not going to consider this. Let us consider later on, because we do not have this part. So we're going to consider this part to the last part, since we have TH. So at least we can calculate TJ. Then we formulate another equation again, so that we can use it with TG and TF. We can't use these two, because there is nothing that we are going to have two unknown values. So it's useless for us to use this middle part. We are going to consider the one and the one at the end. So that means our part is going to be given as NC over ND, which is equal to, we are going to take TJ squared over TH squared, since we have TH in this case. So what is now is going to be the ratio of NC over ND. From this ratio that we are given here, we are given that ND is equal to 1 over 10 of NC. It is equal to 1 over 10 of NC. So what does it mean? I can write my ratio in terms of NC over ND. If I am to cross multiply this image of 10 times ND, we are going to have 10 ND, which is equal to 1 times NC, which is NC. So in order for us to obtain NC over ND like this, what are we going to do? We are going to divide by ND both sides. The moment you divide by ND both sides, you are going to obtain NC over ND. So that means 10 is equal to NC over ND, which simply means 10 is same as 10 over 1. So it simply means where there is NC over ND, I'm going to use 10 over 1. So here I'm going to have my ratio of NC over ND as 10 over 1, which is equal to TJ. Do we have this? We do not have this. We're going to calculate. So for the meantime, we are going to calculate the number of teeth, calculate the number of teeth on gear J, the number of teeth in this case on gear J. So we are going to consider the gear J, which is TJ in this case. We have TH, the teeth on H here is given as 24. We are already given this. We are going to consider the 24 there. So this is going to be 24 squared. Remember, this is TH squared. So in order for us to find the teeth on J, we can cross multiply. So that means 1 times TJ squared, we are going to have TJ squared, which is equal to 10 times 24 squared. So we're going to have 10 times 24 squared. So in order for us to find the teeth on J, since this is a square, we are going to introduce the square root both sides. So the square root must cover everything. That means we are going to obtain the number of teeth on gear J in this case, all right? So that was the whole idea of our question, which is going to be something like 75, 8, 9, 4, 6, and so on and so on. So we are considering the number of teeth. So we are going to approximate this to the nearest whole number. So therefore, to the nearest whole number, this can change into 76. So that means the number of teeth on gear J in this case is going to be 75 teeth. So we are going to obtain 75 teeth. We have the number of teeth on gear J. But is it what we are asked? No, this is not what we are asked. The question needs us to calculate the number of teeth on gear F and gear J. But we are limited on this formula. We are limited to use TJ and TF because we do not have these. We do not have these two. So, but we can calculate TH. We can calculate TJ, I mean, because we have got TH, so we can use the last ratio. So with this now, remember what I said, from the concept that we have the same reduction, the ratio of reduction is the same. From that concept alone, that these ratios, they are the same, the ratio of reduction is the same. It also means that the center distance is also equal. So if you understand this concept, you are going to consider now the center distance between those shafts that we considered, because we are considering between the two shafts here, the center distance between the shaft F and G, between H and J. That is why we are given the modules in this case, these modules between F and G, between H and J. So with this part, we are going to formulate a formula for the center distance in this case. All right. So let us have our formula. So this one, you're just going to leave it apart. So remember the formula for the center distance. The center distance is supposed to be given as the module over 2 into, if you are considering TA plus TB, in this case, the ones that are meshing each other, like connected to each other, A and B. So in this case, we are considering what? We are considering F, all right, sorry, let us put our diagram. We are considering F to G and also H to J. So this is what you're going to have. So you're going to consider these 2 points. So meaning to say, we are going to consider the center distance between, let us have for F and G in this case, we are going to have M over 2 into, instead of TA plus TB, it's going to be TF plus TG. TF plus TG in this case. So this is going to be TF plus TG in this case, which is equal to, again, for the points now, we say the other points is going to be J and H. So between the points J and H, we are going to have this as TH. All right, TJ plus TH, or you can write this as TH plus TJ in this case. Meaning to say, we are going to form an equation from this part. Because now we calculate, we have this TJ, the purpose of calculating this, we have it now. So we can substitute now in place of TJ. So we are going to see that TF and TG, these ones are the ones that we are supposed to calculate. Remember, these are the ones that we are supposed to calculate. We are going to remain with them again, TF and TG. So what is the module that we are going to, let us substitute here, because we have this part, the module between F and G, that is the module between F and G, we said it is given as what? As 6, between F and G, that is between the shafts C and E, that is the module between F and G, which is 6. So we are going to have 6 over 2 in this case, all right? So between F and G, it's going to be 6 over 2 into TF plus TG, we do not know this value, which is equal to, remember the one for H and G was 8, so it's going to be 8 over 2 into TH plus TJ. We have these ones. Remember TH, we have it originally, we are given TH, which is 24. So we are going to take TH as 24. So that is TH in this case is going to be 24 plus TJ, which is the one that we calculated before, that is 76. So that was the whole concept of calculating TJ, so that we use the center distance between these, which is the same. So you are going to form an equation in terms of TF and TG. Remember, these are the ones that you're supposed to calculate. So you are going to remain with an equation, all right, 6 over 2, that is going to be 3 into TF plus TG, in this case, which is 8 divided by 2, that is going to be 4 into 24 plus 76. All right, so just combine everything. On this part, you're going to obtain 400 in this case, which is equal to 3 into, that is TF plus TG. So in order to obtain TF plus TG, you can divide by 3. So we are going to remain with an equation for TF plus TG in this case, which is going to give us 400 divided by 3 is going to give us 133,333, like that, to 3 decimal places, all right? So we have formulated, we are now having a simultaneous equation. All right, we are now having a simultaneous equation, so you can refer this as our first equation. All right. So the question is, where are we going to have another simultaneous equation, or where do we have any equation which consists of TF and TG at the same time? Do we have such equation? Let us go back to the information that we had before. Remember what we had before about from our ratio on the input and output here. We said NC over ND can be given from these two formulas, if you still remember here, where we say these ratios are the same from the concept that TG is equal to TG over TF is equal to TJ over TH. We said we can write in terms of TG and TF. We can write the same ratio in terms of TJ and TH. And we used this part because we wanted to calculate TJ. So this time we are going to take this part now because we have formulated an equation that has got TF and TJ. So we are going to consider this part now, where we are going to consider the speed to TJ, TG, and TF. This is the one that we are going to consider now. All right, so let us take this part. I want you to see what is going to happen this time. Let us take this. I want to take it aside where we have that center distance here. All right, so we are taking this equation as it is. NC over this part, remember? So I'm just gonna rewrite this one as it was before. So we said this was given as NC over ND, that is the input over output, is equal to, we obtained TG squared over TF squared, you still remember, which was equal to TJ squared over TH squared. And I explained that we used this part and this part to calculate TJ. That is the one that helped us. The TJ that we calculated here helped us now to formulate an equation whereby we've got TF and TG. So we are no longer going to use this. We have already exhausted this part. We are going to take now the speed with the TG. This time we are going to equate to this part. So meaning to say our speed, remember we said NC over ND. This one, we are not going to repeat. We calculated this ratio before. I explained this part here. NC over ND is going to give us 10 over 1. We explained this part. So we are going to have 10 over 1 from our ratio. This is going to be 10 over 1 is equal to what? TG squared over TF squared. So we can write, or we can cross multiply to remove the fraction. Let us see what we're going to have at the end. If you cross multiply, 1 times TG squared is going to be TG squared, which is equal to 10 times TF squared. We are going to have TF squared. So as we can see here, we can write TG in terms of TF. How? We can simply remove the square by introducing by introducing the square root in this case, by introducing the square root both sides. we remain with the TG. So that means our TG is going to be given as the square root of 10. So we are going to simplify the square root of 10, which is going to give us 3,162, the square root of TF squared, that is TF. So we have a ratio, or we are going to consider this as the second equation, which consists of G and F. We have got G and F. We've got G and F. So we've got two equations that we can consider. So this is our second equation. So as you can see, we can calculate the value of TF, the number of teeth that we have on F, since this is what we are supposed to calculate. Our question is calculate TF and TG. So we have formulated simultaneous equations from the center, distance, and also from the ratio of the speed to the product of the driven over the driver, and the concept that we have the same ratio. That is where we ended now. So at this stage, we can calculate TF and TG. So as you can see, from equation 2 already, TG is the subject, so I can substitute in equation 1 TG in this case. So we are going to substitute equation 2 into equation 1 into equation 1 in this case. So our equation 2 in this case, in place of TG, we are going to substitute this part. So we are going to have TF plus TG, of which our TG is given as 3,162 TF, which is equal to 133,333, like that. All right, so this is, we're now having in terms of F, this is same as 1F. So if you add 1 plus this, you're going to have 4,162 TF, which is equal to 133,333. So how are we going to obtain the value of TF? We can divide both sides by 4,162. Both sides by 4,162. That means we are going to have the number of teeth on gear F in this case, which is going to give us 32,0358 and so on. So we are considering the number of teeth in this case. So we are going to consider this to the nearest whole number. So to the nearest whole number, it follows that our TF is going to be 32. This 0 cannot change. So we are going to obtain 32 teeth in this case. So we've got the number of teeth on F. So how are you going to find or determine the number of teeth on G? You can substitute in equation 1. You can substitute in equation 2. But it's best for us to substitute in equation 2 because already we have made TG the subject. TG is equal to 3,162 TF. So that means our TG is going to be equal to 3,162 times TF. We calculated TF here, we got 32 teeth. So that means our TG is going to be given as 101,184. To the nearest whole number, this is going to be 101 teeth. So we are going to obtain 101 teeth. So that is our question, to find the number of teeth on gear G and also on gear F. But as you can consider, guys, you have to play around with your equations. Manipulation of formulas is what is needed in this case. How to manipulate your formula from the ratio of speeds in this case, and also considering the same ratios from the information that we are given, that these two are having the same, the ratio of reduction is the same. It follows that the center distance is also equal, and also from the ratio of speed that we are given between ND and NC, then we can formulate our equations depending with what you are given. And also on the center distance, we are going to consider the center distance between F and G, the center distance between J and H, with the given corresponding modules. So the modules that you are going to take, you are going to take them correspondingly from our diagram we are given in this case. All right, this is our diagram here. We were given, I want you to see on our diagram here, we are given that the module that is connecting between the shafts E and D, the module that is connecting E and D in this case, that is this E and this D, is 8. So we are considering J and H, these ones, H and J. And also knowing on the driving part to say on the input, F is going to drive G. And connect to the shaft, GH is going to drive J. That is the whole concept. So if you consider this, we now have your driven, and these are the drivers. So these ones are our drivers in this case, whereby these are the driven. That is the whole concept. Take your information properly, understand your information, substitute your information properly. You can answer as much questions of this nature from your exam. But for now, that's it. Till we meet again.